Hi everyone, welcome to IIT NEET Physics Concept channel. In this lecture, we are going to discuss about a straight line. Okay, this chapter comes under the category of mechanics. It is a branch of physics. Okay, and it is belongs to the class 11. Right now, let us start quickly. Right, so the car is traveling in this direction. That means in a straight line. So this is called motion in a straight line. So in this chapter, the topics are going to discuss mainly, that is introduction part and frame of reference, distance and displacement, instantaneous speed and average speed, instantaneous velocity and average velocity, acceleration, relative velocity, kinematic equations, acceleration due to gravity, and some graphs. So these are all the important points and the topics we are going to discuss in this lecture. Now come to the introduction part, that is the mechanics. Okay, so in the mechanics, generally what is the mechanics? Mechanics actually it is a branch of physics. The main topic will cover in this mechanics, so in the entire complete physics subject. So the mechanics is a one field that going to discuss about the all the motions of an particles. Okay, the particle may be rest or in motion, okay, whatever it is. Okay, the moving objects, it's going to discuss about completely the moving objects. So what we are going to discuss, the mechanics means like a speed, velocities, okay, and the displacements, accelerations, like this, all the things we are going to discuss. The completely the information which is giving the mean with the help of the equations, all those things will cover in this mechanics chapter. So mechanics are mainly divided into three topics. Okay, that is, number one is the statics. Statics means in this field we are going to discuss all the particles which are at rest. Okay, that means the object is not moving. Then what is the rest? Generally the rest means here with the help of the suppose I kept one particle like this here. After some time I came here and again checking that the particle is here only, the object is here only, not moving. Okay, so that is called rest. Okay, so that means with the help of the time you are telling that, so it is not moving. Okay, or also you can tell with the help of the displacement or maybe distance or length. Okay, well initially wherever it is there, so the position is only still here only, so like that, though all the particles we can say the rest. Fine. Next comes kinematics. The kinematics is going to discuss about the motion of objects completely. Right, here suppose if I push one ball, okay, by applying some force on this one, so the ball will move up to some distance and it will be rest. See, in this kinematic section, so we are going to discuss about the all these things only, about the motion only. Okay, so after pushing the with some force, now what happened here, it is displaced to this much, okay, and this velocity and the accelerations, all the things we are going to discuss. But what is the cause for this motion, we are not going to discuss. The reason behind the motion we are not going to discuss in the kinematics. That is a very very important thing. Next comes the dynamics. The dynamics we are going to discuss the cause for that, the reason of the particle, why it is moving, okay, how much force you are applying, like that, all those things we will going to discuss in the dynamics. Of course motion and also the reason. So this is a small introduction about the mechanics, the statics, this is kinematics and dynamics. Now come to the second topic, that is a frame of reference. The frame of reference means here, see, generally the frame of reference is going to the it is specifies the position of the particle or maybe any any object, okay, using some reference point. Okay, what is the frame of reference? It specifies the position. So what do you need to specify the position? You need a one reference point. Okay, so with the help of this Cartesian coordinate xyz axis, okay, so we are going to discuss. So suppose this is a reference point, origin point O. So with the help of this origin point, so where is a any object, where it is located, like that, all the things we are going to discuss. That is the frame of reference. Suppose here, see, the frame of reference is not fixed here in this case. So where the how you are going to considering the frame of reference, based on that only we have to tell the information about that particle or any object. That means here, see, this is the frame of reference, this person, okay, this boy is standing here. Okay, according to this, suppose if I tell according to this boy, okay, and here there is a one bus, there are some students are sitting on that. Okay, then now according to this boy person, according to this boy, so what happened here? Suppose the bus is moving like this. Now what he says, according to this boy, okay, frame of reference, so he says that, so the bus is moving, and also the two students are also, the children are also moving. Okay, so that is his frame of reference. But according to his frame of reference, what happens here? So these two persons saying that you are also moving, but it's not. Okay, he's standing here only, but the frame of reference is changed here. Second case, first case here, second case according to his these two children's, so the person also moving. Okay, so that is called frame of reference. How you are considering the frame of reference, you have to note down. Okay, suppose if I say that according to this person, okay, this boy which is in the scenes inside the bus, okay, he says that this girl is also sitting. Okay, is not that girl also not moving, but according to this boy, both are moving. So see this one. So this is a difference of the frame of reference, considering the frame of reference. Fine. Now come to the next topic, that is a distance and displacement. Okay, now see why I'm taking this one by one, okay, as a comparison, because very small difference is there between the distance and displacement. Okay, because see, the distance and displacement gives the length only. Okay, but the considering of that length is different. Now let us check how it is. Now this is a tabular form. Now the distance here and displacement is here. So in the distance, see, what is the distance? Generally the distance is that it is the actual path length covered by a moving particle in a given interval of time. Okay, according to the some interval of time. Okay, now what I am telling, that the particle is moving and it pass some path. Okay, suppose your particle is here now. Okay, now it is moved to here. Now what is the path distance? So from here to here you have to measure. That's it. That is the distance, the path length traveled by the particle in this way only. Now second, here the displacement, the shortest distance directed from initial position to final position, irrespective of the path, is called displacement. Okay, suppose the particle is not in a straight line, suppose it moved in this way and reached to this same position B. Okay, here also A and here also B. See this, for the first case the particle is moved in a straight line from A to B only. But in the, suppose if I take this in different situation like that, the particle is moved in this long distance and reached the same point B. Fine. Now see the displacement definition. The shortest distance. Now what is the shortest distance between the A and B? This is the shortest distance. Okay. The maybe the path length the particle traveled is bigger compared to the first case, but the displacement is always considered the shortest. So that means this one is the shortest. Okay, that is the displacement, and this is the also distance. Distance and displacement is same here in this case, but in this case is it same? No, distance is this one but displacement is this one. That's why I'm taking the difference, okay, in a same slide only. Now here also another definition given, the change in position. Of course, the change in position, right? So this is the distance and displacement. Now see, it is a scalar quantity. Distance is a scalar quantity. Okay, so distance is a scalar quantity. Means the path length. Path length is the only that is called scalar quantity. Means it has only magnitude, not a direction. That's why it is called scalar quantity. And the dimension formula, okay, length, because the unit for the distance is meter only, right? That's why the dimension formula is L. And the distance is always positive, means greater than 0 means always positive only, okay, not a negative. Means not a you cannot measure the -5 meter length, okay, you always measure with a positive sign only. That's why the distance always positive values. And it has many values. Distance can have many values, means I will tell you what is that in the next slide. And never decrease with time, it cannot decrease with time. So if change the time, always the distance will be increased, not a cannot be decrease with the time. Next, in this case that is a vector quantity, because it already it is specifying the shortest distance, so you always consider the shortest distance only, so initial to final. So that means here it has definitely the direction, of course the magnitude is always there, so direction and magnitude, that's why it is a vector quantity, that is a displacement. Dimensional formula is same, because the unit for this one is meter only. And displacement is maybe a equal to 0, or maybe greater than to 0 or less than 0, because the displacement may be a plus, minus or 0. That also I will tell you how it will comes. And it has single value, because it is already telling the shortest distance, only means single value, not like a many values like a distance, okay. And displacement can decrease with time, of course. See, so the path is traveled from the particle is traveled from in this longer path, so okay, but displacement is this one only. So that means comparatively in these two path, it takes a much time, but it takes a less time, so the displacement is decreased with time. So that is a thing you have to understand. And next, see what happened here. In the one particle is moved in this way, and also maybe the particle after that, what happened here, you can take the shortest distance like this. Maybe the particle moved in this way, but you have to consider the always the shortest distance like this only, okay. Now see, the distance is greater than 0, of course, okay. And it is many values, I will tell you what is that many value again, right. So this is the way you have to consider the distance, this is one. Maybe the particle moved in this way, but the displacement always you have to consider this shortest, okay. And next, this is another particle like this, okay, it is moved in this way. So what is the length? Let us take here 3 meters, okay. And later it moved in this way, and let us take here it is a 2 meter, suppose. See, the distance is only single value, no, it is a two values, it is a two values. See, the distance you have to consider the 3 meter, okay, to this direction, and also you have to consider the distance in this direction. So 3 plus 2, 5 meters is the distance. Now what about the displacement? Displacement you have to consider only shortest, means like this, okay. So this is a displacement, so this is a vector form, right. So see here, so the distance is many values like this, but displacement is only single value, so never decrease with time. So it is not possible to decrease with time, but displacement can decrease with time. So see, this is the way you have to understand what is the distance and displacement. Now what is the displacement for this example? If I take displacement, so how to find out? By applying the Pythagoras theorem, okay. Under root 3 square plus 2 square, okay, under root 9 plus 4, okay, root 13 is the displacement, fine. Next, now see another example here. So the particle is like this in a circular way, okay, and it is moved from this point. Let us take here A, in this way up to here. Let us take here, it is a B point. Okay, initially here, next come to this point. Okay, now see what is the displacement in this case. Now what is the distance and displacement? Distance is this one, path traveled, but displacement is here, shortest distance. Now suppose if I give the some parameters like that, it is a center of the circle, okay, and this point and this point, the two initial and final points are making angle with the center like a theta. Now to find out the displacement AB. Now how to find out the displacement AB in this case? Okay, to find out the displacement in this case, now what I'm doing here, just I'm taking the center of this length AB like a X. Now if I extend the one line like this, which is passing through the center of the circle, right, now the theta will be divided into equally, it is a theta by 2, and also here theta by 2. If I measure this XB, then double of this XB will come the total length, that is the AB. So how to find out this XB? By applying the sin theta. Sin theta is equal to opposite is how much here, XB, by adjacent is the this one, this is the, let us take radius as R, capital R. Now here sin theta is how much here, theta, actual theta is not theta, theta by 2 you will get. Now XB is equal to R sin theta by 2. Now this is XB. Now the remaining AX will come how? By doubling this value, that means AB is equal to 2R sin theta by 2. So like this you have to understand the distance and displacement. Now here another example, this is a particle. Okay, on this particle I am taking one point here. Okay, on this sphere ball. Now what happened here? Now it is moved like this, and the point is here. Now means initially the point was here, okay, in the bottom of this sphere, and after that it moved in this way, right, up to here, and this point comes to upside. So that means here it is. Now find out the distance and displacement in this case. Okay, the distance means here path travel. Now what is the path travel here? So from here to here means here this complete circumference. This is complete circumference. But it not moved the complete circumference, it is moved into half circumference of this sphere. So what is the circumference generally for the any sphere? That is a 2 pi r. But is moved how much here? 2 pi r only, because it is half of this circumference, means pi r. If I take the radius is r, capital R. Okay, so this is a pi r. It comes pi r because this is the half circumference of the this sphere. Now what is the displacement? Displacement is initially here it now. Now it is a final. Now take this one. So this is the shortest distance, that this is the displacement. Now to find out the displacement again, now apply the Pythagoras again here, that is under root. Okay, now what is the length of this one? It is a radius r. Now here is also total 2r. Now this is the length is half circumference pi r. So that means pi r whole square plus 2r whole square. So like this we will find the displacement and distance of this circle. So this sphere. Okay, the r will come outside, root pi plus 2. So this is the distance and displacement, and you have to observe very clearly what is the distance and what is the displacement.